Text-to-speech technology has improved significantly the past few years, and with OpenAI Text-to-Speech API, it lets you convert text into natural human sound speech. In this tutorial, we'll learn how to use Python to build a text-to-speech desktop application using OpenAI's Speech API. On the screen is the desktop application we will be building. We can change the voice, alter the speech speed, play the audio, and save audio as a WAV file. On top of that, you can customize the app based on your projects and workflows to make it even more functional. Open a terminal and install OpenAI PyQt6 PyAudio and Wave Python libraries with the command pip install OpenAI PyQt6 PyAudio Wave. Create a Python file and name it app.py and open the file with your code editor. In the app file, import the sys module. Next, import the datetime module, which supplies classes for manipulating dates and times. Then, import the I/O module, which provides the Python interfaces to stream handling. After that, import the wave module for reading and writing wave files. Include the PyAudio module to provide Python bindings for port audio, the cross-platform audio I/O library. From the OpenAI package, import the OpenAI class, which is used for interacting with the OpenAI API. For the PyQGUI application, import the following classes from pyqt6.qWidgets. QApplication for handling application-wide resources and settings. QTWidget, the base class for all UI objects in Qt applications. QTextEdit to provide a text editing widget. QPushButton to create clickable buttons. QComboBox for a drop-down selection box. QLabel to display text or images. QSlider to incorporate sliders. QSpacer item to manage space and layouts. QStatusBar to provide a status bar for the main application window. QStyle for styling the application. QFileDialog to enable file browsing window in the application. QTVBox and QHBox for vertical and horizontal box layouts respectively. From PyQt6 Qt Core, import Qt for core, Qt functionality, and QThread to handle threading operations. Finally, import QIcon from PyQt6 QTI to handle icons in the application. Create a class named AudioPlayer, which inherits from QThread. This class is used to handle the playback of audio data from a byte stream. Inside the AudioPlayer class, define a constant named chunk with a value of 1024. This constant determines the number of audio frames to process at once. Define the constructor method with parameters self, audio bytes, and an optional parent parameter set to none. This method initializes the AudioPlayer with the provided audio data and sets up necessary attributes. Use the super function to call the constructor of the QThread, passing the parent argument. Initialize the audio bytes attribute to hold the audio data. Set the paused attribute to false to control playback state, and initialize an empty list called frames to store audio frame data. Define the run method to handle the audio playback. In this method, open the audio data for reading using the wave module and an I/O bytes I/O object created from self.audiobytes. Use the RB mode to read the data as binary. Create a PyAudio object to manage audio streams. Then, open an audio stream using the PyAudio object. Configure the stream with the audio format obtained from the wave file's sample width, the number of channels, and the frame rate. Set the output to true to enable audio output. Read audio data from the WAV file in chunks specified by self.chunk. Use a while loop to continuously read data until there is no data left. Inside the loop, check if the playback is not paused by evaluating the self.paused attribute. If not paused, write the data to the stream and read the next chunk. If paused, use QTthread's msleep method and set the msleep duration to 100 milliseconds to pause the loop execution briefly. After exiting the loop, stop the stream using the stopStream method, close the stream, and terminate the PyAudio object to clean up resources. Emit the finished signal to indicate that playback is complete. For the entry point, insert an if statement to check if the script is the main script being executed. Next, create a list named Voices and populate it with the names of OpenAI Text-to-Speech voices. Create an object named OpenAI Client by instantiating the OpenAI class. This object will be used to interact with OpenAI services. Create an object named app by instantiating the QApplication class from the Qt library. Pass sys.argv to it, which contains command line arguments. Set the style of the app object to Fusion using the setStyle method. Create an object named AppWindow by instantiating the AppWindow class. This object represents the main window of the application. Show the app window using the show method to make the application window visible. Finally, exit the application using sys.exit and pass eep.exec to it. The exec method of the app object starts the main event loop of the application, which keeps the application running until it is closed. Create the AppWindow class that inherits from Qt widget. This class is designed to serve as the main window for an application. Inside the AppWindow class, create the constructor method init with an optional parameter parent set to none. This method initializes the window with basic configurations and setups UI components. First, call the constructor of the base class using super init to ensure proper initialization of the Qt widget class. Set the window title to OpenAI TTS v1 using the setWindowTitle method. Set the minimum size of the window to 800 by 600 pixels using the setMinimumSize method. Apply a default font size of 13 pixels to the window using the setStyleSheet method. Set the window icon using the setWindowIcon method, providing it with an QIcon object initialized with the path to the icon file. Initialize two attributes, audio bytes and playing, to none and false respectively. These will manage the audio data and playback status. Initialize the AudioPlayer attribute to none. This attribute will handle audio playback functionality. Create a dictionary named layout to store the various layouts used in the window. Add an entry main to this dictionary and assign it a QTVBox layout object. Set this QTVBox layout as the main layout of the window using the setLayout method. Call the initUI method to initialize the user interface components. Call the configSignals method to configure the signals and slots for the UI components. Create the initUI method to set up the user interface components for the AppWindow class. Initialize three dictionaries, combo box, button, and label, to store references to combo boxes, buttons, and labels respectively. Add a QTH box layout to the voice key in the layout dictionary. Configure this QTH box layout to have 0 margins on all sides using the setContentsMargins method with parameters 0, 0, 0, 0. Add this QH box layout to the main layout of the window using the addLayout method. Create a Q label for voice selection, set its text to voice, and add it to the voice layout using the addWidget method. Store this Q label in the label dictionary under the key voice. Create a Q combo box for selecting voices. Set its fixed width to 200 pixels using the setFixedWidth method. Populate it with voice options using the addItems method and set the default selected index to 0 using the setCurrentIndex method. Add this Q combo box to the voice layout and store it in the combo box dictionary under the key voice. Create another Q label for speed control. Set its text to speed and add it to the voice layout. Store this Q label in the label dictionary under the key speed. Create a Q slider for adjusting the speed. Set its orientation to horizontal using the setOrientation method and define its range from 25 to 400 using the setRange method. Set the initial value to 100 using the setValue method. Connect the value changed signal of the slider to update the speed value display dynamically. Add this slider to the voice layout and store it in the object speed slider. Add a Q spacer item to the voice layout to provide some spacing using the addItem method. Create another Q label to display the speed value dynamically. Set its initial text to a formatted string representation of the speed slider's value and add it to the voice layout. Store this Q label in the label dictionary under the key speed value. Create a Q push button labeled AndConvert for initiating the audio conversion process. Add this button to the voice layout and store it in the button dictionary under the key Convert. Create a Q text edit for text input. Add it to the main layout of the window and store it in the object text input. Create a QTH box layout for media player controls and add it to the main layout. Create another QH box layout for additional buttons. Add this layout to the main layout. Create a Q push button labeled and play, initially disabled, and set its icon to the play icon using the setIcon method. Add this button to the buttons layout and store it in the button dictionary under the key play. Create a Q push button labeled and save, also initially disabled. Add this button to the buttons layout and store it in the button dictionary under the key save. Add a stretch to the buttons layout to push all buttons to the left side using the add stretch method. Finally, create a Q status bar for displaying status messages and add it to the main layout of the window. Store it in the object status bar. Create the convert text to audio method to handle the conversion of text input into audio using an API and manage the UI updates based on the conversion status. First, obtain the text from the text input field, replacing all new line characters with spaces and reducing multiple spaces to a single space. Insert an if statement to check if the input string is empty. If it is, display a message on the parent status bar saying no text to convert, and then exit the method. Retrieve the selected voice from the combo box and the speed from the speed slider, adjusting the speed value by dividing it by 100, 0. Use a try block to handle potential errors during the audio generation process. Within the try block, call the speech create method from the OpenAI client's audio object with parameters for model, input text, voice, response format set to wave, and the adjusted speed. Assign the response to a variable. If an exception occurs, catch it and display the error message on the parent status bar, then exit the method. After successful audio generation, format the current date and time and display a message on the parent status bar indicating that the audio was generated along with the timestamp. Extract the audio bytes from the response object and assign them to the audio bytes variable of the instance. Initialize the audio player with these audio bytes. Enable the play and save buttons by setting their enabled property to true. Create the play audio method to manage the playback of audio data. First, check if the audio bytes variable is none. If it is, display the message no audio to play on the parent status bar and then exit the method. Insert an if statement to check if the audio is currently playing. If it is, stop the audio player. Wait for the audio playback thread to finish using the wait method. Set the playing flag to false. Update the play button's icon to the play icon using the standard icon method with the SP media play parameter. Change the play button's text to play. If the audio is not playing, initialize the audio player object with the audio bytes. This starts a new thread for audio playback. Start the audio player. Connect the finished signal of the audio player to the reset play button method to handle UI updates when audio playback is complete. Set the playing flag to true. Change the play button's icon to the stop icon using the standard icon method with the SP media stop parameter. Update the play button's text to stop. Create the reset play button method to reset the play button to its default state after audio playback is complete. Set the playing flag to false. Update the play button's icon to the play icon using the standard icon method with the SP media play parameter. Change the play button's text to play. Create the save audio to file method to save the generated audio to a file. First, check if the audio bytes variable is none. If it is, display the message no audio to save on the parent status bar and then exit the method. Use the get save file name method from QFile dialog to open a save file dialog with the title save audio file and filter for audio files.way. This method returns the selected file path and a filter. If a file path is provided, open the file in write binary mode using a with statement. This ensures the file is properly closed after the block is executed. Write the audio bytes to the file. This saves the audio content to the specified path. Create the config signals method to connect UI button clicks to their corresponding methods. Connect the clicked signal of the convert button to the convert text to audio method. This setup allows the conversion process to start when the convert button is clicked. Connect the clicked signal of the save button to the save audio to file method. This enables the saving of the audio file when the save button is clicked. Connect the clicked signal of the play button to the play audio method. This allows the audio playback to begin when the play button is clicked. And that's the last method we need to create to complete the application. To use the application, run the app.py file to launch it. Select a voice, paste the content you want to convert to audio, and click Convert. Once the conversion is complete, play the audio to ensure the output is correct. If it sounds good, go ahead and click Save to save the content as a WAV file. That concludes this tutorial. Thank you for watching this tutorial. I hope you found it informative. For more tutorials, make sure to subscribe and don't forget to like the video. If you have any questions or topics you would like me to cover in future videos, please leave a comment below. Happy coding, and I'll see you in the next video.